Look at. I'm Andy, and this is CB, and this is Rust for the Recalcitrant C++ programmer, which I did have to look up.
Programmer or C++? Rust.
Do you want to talk a bit about your relationship with this topic?
Yeah, so I'm a programmer, and I work mainly in C++ in my day job, and so I know nothing about Rust. Up until we did a little bit of preparation for this talk, and I was forced to see a little bit of Rust, just as a preview. But I have avoided taking in anything at all because, like, I don't know, C++ is a big enough subject that, you know, I feel I know it well enough to be able to kind of write stuff in it. Do I really need to learn yet another language? I mean, I also write a little bit of Perl that I use to generate C++. So, I mean, really,
Two is enough.
I think that's enough. And some shell script in order to call the CMake to build the C++ that Perl has generated. So, I mean, really, is there a need for another programming language in my life?
After you've seen Perl and C++, that's presumably put you off learning about programming languages. So I'm a huge C++ fan, love C++. Also, I think, like in common with lots of people who love C++, also hate C++. But I'm also a Rust fanboy. I'm not a great expert. I've done a bit of Rust in various hobby projects and a little bit at work. But I'm sure there's people in the room who know more about Rust. But we're going to go through some stuff about Rust, and I'm going to try and explain why I find these things helpful and exciting.
Yeah, I was going to say, I mean, this list could be like a list of things that C++ could do, but then I read the entire list, and yeah, maybe not. Maybe
towards the end it gets a bit tricky. Yeah, so we're going to talk about some stuff in Rust that I like. So this isn't really going to be an introduction to how to write code in Rust, but you will pick some of that up probably. Okay, so first of all, we probably already talked about this. Isn't C++ just already good enough?
I mean,
how do you feel about that?
Isn't C++ enough? I mean, isn't C++ too much?
Little bit too much for anyone. Yeah.
I mean, really, and if we have to question whether it's too much, surely it is enough.
Yeah. And the criticism of Rust, actually, is that there's a lot of Rust as well. It's not as simple as you might want it to be. Okay, so we're going to start off by talking about some things about using types in Rust that I like. I should say, Rust, just as an introduction to what Rust is, it's a language that in many ways is inspired by C++. Its execution model and its memory model is quite similar to C++. And then syntax and ideas are taken from lots of different places. And my way of understanding what it is, or at least one way of thinking about what it is that it takes some of the best ways to write code in C++ and makes them enforced by the compiler. Okay, so from that onto some very specific examples. First example of one of the things I like about using types in Rust is that it forces you to, or at least gives you the facility to force yourself to handle cases that you might ignore in other languages. So here's some C++ code that I wrote, so apologies.
Yes.
So imagine you've got a service, it holds onto a resource, and from time to time you can ask it for information about, you can gather statistics about how it's been operating, and also it has the ability to get shut down. So there's an obvious problem with this code, right? Depends how you use it, but yeah. So in principle, what you might do is shut it down, and then your statistics gathering process might still want to still be running and ask it for statistics. And it's all going to go wrong. So here is some equivalent Rust. So I'm going to pause for some potential questions about what is going on here.
Okay, so like, I don't know, it looks, it's kind of indented, it's got curly braces. There aren't enough semicolons, there are a few, but like, not as many as I was expecting. So like, I mean, struct, that's just the same as C++ struct, right?
A struct is very similar to a struct in C++.
Yeah, and then the next line looks a bit backwards. I'm guessing that this is a std optional my resource, and you've got the type on the wrong side, and you've got this like pointless equals after the variable name. Is that right?
Colon, yeah.
So what's the comma? Is that like a semicolon that's just lost its dot?
So there's a number of questions.
Okay.
Yes, the type is on the wrong side. It's actually on the right side. The correct.
I left that one open.
It's by putting the types on the right-hand side, you get the with the colon, you get the ability to only specify them optionally, which can be really nice because you can you don't have to put an extra word in there like auto.
Yeah, I have to say it's probably quite nice for alignment too, because you can call all of your variables like 3 letters and everything be aligned, whereas types tend to like vary in length quite dramatically. So I can concede that's.
We should start some practice of naming our variables with the same number of characters as each other. That's the way. If the struct had more than one thing in it, then it would come after that comma.
Oh, hold on. What's impl though?
Yeah. So, but it's
seems like struct part 2.
Yeah, it is struct part 2. So when you declare a struct in Rust, you're not allowed to put anything in there other than the data that it holds onto. If you want it to have methods, you need to make an impl block like this. Put your methods inside there.
It seems weird.
And you can have more than one impl block.
Okay, but is that because you don't have proper header files where you can separate your interface from your implementation, or what? I mean, it feels like you're covering for something.
You don't have proper header files, no. It's slightly weird. So it becomes much more natural when you're implementing different traits, which are a bit like interfaces or abstract classes. And then you will have an impl block for every trait that you implement. So impl my service for iterator, something like that. And you can also, the fact that you can do multiple of these and the methods get added on, it sounds like a terrible thing to do, but I'm sure it could be useful.
Okay, and so you've got impl, which is like...
Here are my methods.
Here's both the declaration and the definition of my methods.
Yeah.
So these look a bit like function definitions, and fn is obviously like the Rust for auto, because that's where it's appearing in the
It's pronounced fun, not fn. What is it? Fun is a keyword, nothing like auto, which means the following thing is a function.
Okay, so it's nothing to do with the return value.
Nothing to do with the return type. The return type is on the right-hand side.
Or not. Or
it doesn't. It's not there, which implicitly means it doesn't return anything useful.
Oh, okay. So that's like
returns
void.
none.
You don't have arrow void.
It doesn't. Sorry, doesn't return none. It doesn't return. It's like void. Yeah.
Okay.
And yeah, it's after.
Alternative choice.
And it's after the return type is after an arrow, which you can see in the second.
Okay, and it's got like ampersand, so clearly it's trying to do something which is like references, but isn't.
Yes, the ampersand is supposed to make you think of references to things.
And mut is clearly short for mutable.
Yes. So the first method takes...
Are they trying to make it easy for C++ programs?
Yes, they are. I think they are.
Okay. They could have made it easier.
Yeah.
Okay, just a quick question. Does it complain if you put semicolons in the places that clearly it's missing from?
Yeah, semicolons have meaning. Let's do semicolons in a minute. So the first method takes a mutable reference to self. Self is like a special word that means...
it means this, doesn't it?
It means this.
Yeah. Yeah, we just get that for free in C++, so...
Yeah, so you have to write self, and that means that you can give a type for self, which can... very helpful. In this case, we're only saying it's either a mutable reference or not.
So you can give a type that might be different from my service?
Yes.
Okay.
Yes, you can have, so it's kind of cool. You can take a box of self, something like that.
Box of self.
Yeah. Let's not get into that. Anything else on this slide? Oh yeah, semicolons. Yeah. So one of the more subtle bits of the syntax of Rust is that if you leave off the semicolon, it means you're essentially returning that value. So the last line in your function will have no semicolon, and that value gets returned. It's sort of a little bit reminiscent of writing Lisp code or something like that.
Well, that's interesting, because leaving off the semicolon in C++ means that you want a confusing error message that points to a completely different area of the code. So, yeah, maybe.
Well, it's continuing the tradition that there's a sort of very subtle change in behaviour for a small.
Yeah, we can get used to
that. Yeah, so semicolon means I'm not using the value of this expression. All right?
So,
that was just anyway. So,
like, and mut self means this is like a non-const method, I guess, and self is now a reference, not a pointer. Do you have pointers in Rust?
I'm going to stick to the safe subset of Rust, in which you can't use pointers. I'm going to say. I'm not going to show you any pointers.
I have a feeling that C++ is more powerful than the safe subset of Rust. I'm just going to make that wild conjecture.
Yeah. Well, you have the unsafe section as well.
So is the bottom one a const method because it doesn't involve the word mut?
It's a bit like a const method.
It's a bit like a const method.
It's much more powerful than a const method. We'll get to that.
You can't change anything in a const method. What?
It's worth mentioning that self doesn't have to be a reference. You could actually be taking ownership of self by calling a method, but we won't go any further on that. So back to the example before we completely lose our thread. This is a similar code written in Rust. This program has the same problem that the original program had, but it's okay because we weren't allowed to write that code.
It doesn't even compile.
It doesn't compile.
After all of that, we learn.
So let's have a quick look at this error message.
In C++, I'd change one of those dots to an arrow and it would be okay.
So yeah, this res thing isn't like a broad pointer that you can use, or at least not in a safe subset. A res was an option type, so you're not allowed to call the stats method on something of type option. What you might have meant to do was to reach inside that option, get the thing out, and then call the stats method on that. So the compiler helpfully gives you a way of doing that using expect. And what expect, terrible name for a method. What expect does is crashes your program if there isn't something in your option with the error message that you supply. So don't do this. Do something much cleverer with your option.
I mean, in all seriousness, C++ doesn't have to crash your program.
No, C++ might launch rockets. No, not in this case, no. What will it do?
Yeah, I was, anyway, Alistair Meredith did a talk earlier on this week about removing gratuitous undefined behaviour, and he had a little list of things that undefined behaviour might cause, and people voted on it. It was kind of quite interesting. Anyway, before we invoke any nasal demons, yeah, in all seriousness, to kind of go back, I probably wouldn't write it that way. If I had something, I would probably like have a service where you could call an open method and get a handle to an open service, which had the gather stats information, and then when you release it, it would like shut down automatically, and the service factory, if you like, wouldn't have an option to do that. I'd probably tend into that direction. But hey, if I had I'd probably use optional, not unique pointer for this, but if I had an optional resource, then as a library item writer, I don't think I'd object too much to going, if it has one, return one, otherwise throw, but all. Anyway, there's some other error handling options. So I'm not sold. I'm not sold.
So I like the fact that the kind of default Rust that I write, the compiler will tell me you might crash at this point, so you should do something better. And the better thing that you should do is something like this, where you, because self.res is an option, you need to find out whether there's something in it, which is what the first half of that if is saying. Do something to handle it. Or like
I really want to put some parentheses around the thing after the left before the brace. Are you allowed to do that? Or is that just going to cause problems?
Are you allowed? I'm not sure.
Okay, no, it doesn't matter.
You shouldn't.
Anyway,
you'll get told off at the very least.
In current C++, we can also declare some stuff in the if statement, which is kind of cool.
So this is an if-let statement, yeah.
Value or, right?
It could value or, yeah.
Yeah. So there are methods like that on the option struct in Rust. You could so the point was you could use the method value or I think it's called I can't remember what it's called. It does the same kind of thing. You could say either do something with the value or
don't,
or do something with this instead. So I've written code that hopefully is the simplest way of understanding that essentially we're saying if there was something inside our option type, do something, otherwise return 0.
Wait.
Yeah.
And auto is spelled sum.
So well, I'm going to defer that question for a little bit until we explain a little bit more about enum types, which is option is an enum type, and this is one way of getting stuff out of an enum type. So in short, sum is one of the things that an option can be. Okay, so that was one thing. Any more to say on that?
No.
Okay, so something else I really like about Rust is that you can get a load of optional built-in behavior for free. So here is my Rust example of a struct which holds on to a couple of pieces of data. But I've also added this derive line at the beginning, and that gives me a whole load of functionality for free. We're invoking a macro which does cool stuff. Give this struct extra functionality, the ability to clone it, to be able to print a debug version of it, and to be able to serialize it into different forms by just writing this one line, and you get a load of stuff for free. So the way that works is things like this. So now there is a clone method on obj, which will give you like a deep clone of this thing. And now you can print a debug representation of it using that middle line. And also you can turn it into JSON in the default way without any kind of runtime introspection, turn it into a JSON string.
Yeah, I mean, C++, like every object, unless you choose otherwise, is copyable, which is kind of a clone. And it should be like a deep clone if that's what you want to do, if you've got complicated stuff. But like all of our standard building blocks, like string and vector, are just copy. So you can just have like a struct of things and it will clone, so that's not a problem. Debug print, not terribly excited about. I mean, like, yeah, maybe useful, but like, we can always add free functions that stream stuff to output strings if we want to do something in a particular way.
But you'd have to write
serialization.
That,
right? There's probably stuff out there. I don't think there's anything. Is there anything standard that does JSON in C++? Yeah, it seems unlikely. We have difficulty standardizing more obviously basic stuff, to be honest. So yeah.
Communicating with the world. C++ not really very strong.
I mean, to be honest, we can take the address of something and just write it to a file. So.
Yeah, roughly equivalent.
Yeah. Okay.
You get this stuff for free.
I'll give you a serialization to JSON as a potentially useful thing.
Right, which is not in the standard library, by the way, but it's in a.
Right. Okay.
It's in a library that everyone uses.
Okay. we can split that one.
But yeah, so you can write these things as well, right? So you can write macros that do similar stuff. So
people have put a lot of work into debuggers to make them really useful because we spend time debugging. I guess it's one of the points, isn't it? Okay. Yeah. No.
Okay, so that was types. There's loads more stuff. Like Rust has a really rich type system that is really a pleasure to use, and you can do a lot of this sort of Haskell style code of like this bug isn't even possible because the types don't express that impossible case. So it's really good, but we've got to move on. Okay. We'll move on to ownership. So everyone knows that good C++ code is really, really clear about who owns which object at a particular time. I thought I was writing good C++ code until the Rust compiler started telling me I had no clue who owned the objects that I was using. And now I've got, what's the syndrome where you get kidnapped and then you start to... So I've got Stockholm syndrome because I love the Rust compiler now for telling me that I was so wrong. So let's look at an example of some C++ again that I wrote. Apologies again.
Yeah, I mean, this is bad, but it's obviously bad because you're explicitly invoking std_move in a place that isn't obviously library code by somebody who seems to know what they're doing, which is a sign you should leave it alone, and it was probably correct. Although the fact that you're looking at the code is also kind of a little bit of a warning sign. So yeah, I mean, obviously, printing something after you've moved from it is bad, but that's why std_move doesn't often appear in, basic code that's doing the right thing. So yeah. In fact, I mean, it's a lot worse than this. I could write something that's like, wrong, but in a much less obvious way.
Yes, yeah, you definitely could. Do we have an example of that?
I think I might have done, actually. Yeah, so here's something that is... I haven't even shown... So I wrote this just to show how terrible the world can be. So I've written a class in C++ called Blob that contains a data member called data. And actually, to be honest, the design of the class it may be a little bit old-fashioned. It's got a data member that returns a const char star. And so it's like a bit of an old-fashioned interface these days because you probably return a string view. But then I've got another function that is, returning a view of some data. And I think it's possible for the function oops to work correctly, depending actually on the implementation of data. But with the obvious implementation, it's probably wrong. But probably wrong isn't good enough for the translation unit that contains oops to be diagnosed by a compiler as definitely wrong. And the thing is and the other thing that I kind of quite like about the implementation for this example is there's no kind of new, there's no taking address of a local variable. There's just a few subtle warning signs that something might be bad here. And I think we were playing with some examples, and occasionally you can get the compiler to say, hey, you've returned a string view to memory that isn't owned. But this particular example, I checked it before, and the compiler didn't warn on this translation unit or on the translation unit that called oops. And yeah, I got Valgrind to complain about this. Yeah, and so oops, yeah, it's true.
Oops isn't oops.
Oops is probably where the oops lies. But yeah, it would also be possible for const char star data, for that to be implemented to return a pointer to a fixed string that's just a compile time string that never changes. And then oops doesn't actually have any problematic behavior. It might ignore the constructor parameter. It might not initialize data, the data underscore member, and data might not be related. You can't actually tell that from here, and that's why the compiler has a difficult thing.
I would question the name of the method data in that case.
But what's interesting, it's got none of the obvious warning signs of I've newed memory or I've taken address of a local variable, and yet it's still, to an experienced C++ developer, should be ringing warning bells.
Yeah, okay. So let's briefly look back at the C++ example, not to say that it's a good example of anything other than it has the same structure as this Rust program and the same semantics as this Rust program. Because lots of things get moved in Rust. Move was added to C++ quite late in its life, and so, I would argue that the natural way of passing arguments would be to move them, but we kind of can't have that in C++. But you can have that in
I
Rust.
would argue that's not natural, but I mean...
Right, well, you might be right. Okay, so we make an object, we make a vector, we push the object onto the vector, and then we try and look at that object, and that object got moved in the process. What were we going to say?
Yeah, I was going to say, if you made this the C++ equivalent, you probably end up copying rather than moving.
Yeah.
And there's not the problem in a different way.
Yes, then there would be not the problem in a different way. Fortunately, the compiler tells us in quite clear language that we did something wrong here. And I guess my argument is that moving a lot is quite good, but only if you have this kind of protection. And in Rust, you do have this kind of protection.
Yeah, and I'm saying that moving should be explicit, and then you can see where the problem is in your C++.
Yeah, but moving's really cheap and cool. So why would that be the explicit thing and copying be the implicit thing?
Because it's unintuitive to call something with something you have and then have the thing disappear on you. That seems unintuitive. I do a lot of C++, and that's why I think any alternative...
Having it copy and cause you a bug, which is pretty much 99% C++ copy behavior.
Yeah, so yeah, I mean...
Okay, let's move on.
Yeah,
I'm willing to move on.
I think copying is quite surprising behaviour, but arguably moving is quite surprising as well, but it is cheap.
I don't know. In assembler, move normally means copy.
Awesome. Okay, so another thing about Rust that's really cool is that it does what I've always wanted things to do with immutability, which is that it's nothing to do with the type, it's to do with you say this variable is immutable, and all the things inside it are also immutable. If it's immutable, here's some more C++ I wrote,
Nice.
with a classic example of how const doesn't do what you want, because
you wrote the class incorrectly.
Because I wrote the class incorrectly.
Yeah. I mean, const isn't part of the type. It's like a CV qualifier, obviously. So it's qualified as the type. Yeah. Alternative choice, I think.
So my objection to this code, or what happens within this code, is that I know that const doesn't do this for me, but what I want is to be able to say, give me an immutable parent. I'm sort of using wishful thinking here, wishing that by making it const, I was getting that. I'm not getting that. In order to have that, I would need to have, I'd have to have methods that have const alternatives, and those are the ones that get called because the thing was const.
Well, I mean, so here you've got a struct parent, and it owns a pointer to a child. It doesn't own a child. Parents don't own their children. They're just responsible for them in some vague way.
For example, holding a unique pointer to illustrate that you own it.
Yeah, but if you did, completely own your child, so if it was just a direct member, then you'd get the kind of behaviour you want, that if you had a const parent, all of its members would be. But right, if you've got a pointer to it, that's not kind of that's not enforced, because that's not necessarily the relationship you want. And if you want that, you probably want a class with some accessor methods and the methods that give you a pointer or reference to a child should be marked const if they're const methods, and you give you a const if you want it to. So you get the choice of how to design your class. And C++ developers are all pretty used to peppering our code with a lot of const, which is a good
How does that feel?
Kind of. I mean, at least we get to make the choice.
Yeah. Yeah.
And we have more const stuff. We have const export and const init stuff.
Yeah,
We've
so
got
much
more. And const eval.
For me, Rust does immutability the way I would like it to work, which is that everything's mutable by default, and that the immutability goes all the way down through the object. So
what's a box?
Here's some Rust. A box is a bit like a unique putter. Yeah.
Doesn't sound much like it, but okay, fair enough.
So a box is a way of expressing ownership of something that you don't know the full type of. So in this situation, child is a trait, which is like an abstract class or an interface. And so you couldn't just say child : capital C child, because the struct wouldn't know what size it was then, because if you're basically saying I'm holding on to that thing by value. So if you want to hold on to something you don't know its type, you're going to need a pointer. So a box is a pointer which expresses ownership of that thing.
It sounds very similar to C++'s issues, that if you've got a struct and you want to contain something, you need to have a full definition so you know its size, but you could have a pointer, you could just have a forward declaration of that type. So, yeah, interesting.
Yeah, so it's exactly the same problem that C++ has, but you're able to express the fact that you own this thing by pointer in Rust.
Okay, we have owning pointers in C++. What was the difference again?
Well, one of the differences is that you get this immutability behavior.
Oh, okay, so it's that you're consting into...
So it doesn't like that, because child is not mutable, because the parent variable is not a mutable variable. I'll give you a second to read that.
Yeah, I mean, you probably have to read that a few times before it made sense.
My summary is, because parent is not mutable, you're not allowed to change child. The reason you're not allowed to change child is because parent owns it, and we've expressed that ownership in the type of parent. That's just how I want mutable to work.
Okay.
Instead of did I put the right const in the right places?
No, I don't feel sold on this. Maybe it's making a slightly different choice on defaults, but
yeah. So the definition of parent doesn't have any const in it, right? It doesn't say anything is immutable.
That is true. Yes.
Where I get to say something is immutable is when I say let parent, and I didn't put the mute keyword there, which means
Okay.
my parent can be modified. And that just flows all the way through to all the stuff inside parent.
Okay, so
really like
you're
it.
just saying that some of your indirection types, like box, are by default properly implementing consonantics. Yeah, okay.
If you like.
Good for us.
If you like. It works
Good
the way
for
I
us.
want it to work.
Fine, yeah, good for you.
Okay, let's move on.
Am I winning still?
Yeah, I think you're winning, yeah.
Oh, good.
So I called this section enum types, but you might know them as algebraic types or something else. So these are a way of expressing that a type can be something or something or something else or something else. Sort of like a union.
A union, exactly, yeah. Structs and versus or, yeah. So a struct is this thing and it's this thing, or it's plus, it's this thing, union with this thing, whereas, whereas a union with it's one of these types. Yeah.
So just thinking mathematically, it's just nice and neat that you can have an or relationship or an and relationship, and that's all built into the language.
We have unions.
Yeah, C++ does have unions,
Yes.
yeah.
So, good.
Yeah, yeah. So we're all at evens, yeah. I honestly, when I try and code in languages that don't have this, I feel really sad. It's a really awesome thing. Let's look at an example. So this is my copy of a type that's in the Rust, somewhere in the Rust libraries, or some Rust libraries that I've used. So this is an IP address that could be either an IP4 or an IP6 address.
I'll trust your IP6 addresses.
I looked it up. I probably looked it up wrong. But
okay.
Yeah.
No, I kind of believe you. It's just like I'm still waiting to move to IP6 properly. It's been threatening to do it for decades. But like, we have NAT. We have NAT. And carrier grade NAT and things.
So IP addresses aside, this is a class that is either an array of 4 bytes, which is what a U8 is, 8-bit numbers, or it's an array of 6 16-bit numbers. That's what those...
Yeah, in assembly we just have like some bytes and we'd only use the first 4 if we were on IPv4. But yeah, in C++ we could union this.
You could union that, yeah.
This,
But unlike how with union, nothing works the way you would like it to.
Really?
In Rust, everything works the way you would like it to.
Oh, no.
That's right. So I'll move it to my pocket. Or...
Sounds like a really horrible option, but how would you feel about using it to help?
That'd be fine.
Is that right?
Great problems, Andy.
Yeah, it could be.
I think his microphone has rusted.
We'll find out if I'm the problem when we use a different mic.
2, 2, 2, 2. So if you hold it like here, that's great. Mute this.
1, 2, 1, 2. How's that? Okay, so this is how you use one of these enums. So you can write a match statement, match is a keyword, and say I want to match on this thing, and then you can handle the 2 different cases, and you get fully type checked logic inside the different cases. So,
Okay.
So A here is an array of 4 8-bit numbers, and B is an array of 6 16-bit numbers.
Okay, well now I've seen this. You don't just want a union, you want some sort of a discriminated union.
Yes.
So, yeah, we can do this in C++. We've got variant. So yeah, I can do the same thing in C++. I can have a struct that's v4, and I've guessed that U8 might be an unsigned char. Yeah, probably on most of the stuff platforms I use is.
Did I mention that Rust has lots of really explicit types that you definitely know what they are?
Yeah, so do we in C++, but we don't seem to use them for some reason. I'm not quite sure why. I could have used, I can't quite remember, is it U16 fast T? No, min T? Or U16? We have those, but like everybody seems to just use unsigned char and unsigned short and then deal with the, well, basically just complain at our vendors if they ever produce platforms that don't conform to what our code already expects, so... Yeah.
Yeah, it's really good.
Anyway, that's not particularly the point that C++ is going to win on. But look, yeah, I've got like 2 structs and a variant that can hold either of these, and yeah, I can I can hold the two types, and I can tell which type it is, because we've got various funky template methods. And
so is this the thing we discovered when we were discussing this?
And as
so this thing exists.
As I was determined to say that we can pretty much do everything, I discovered that actually, in C++ 20, and it may be 23, and this example appears in more than one slide deck of experienced C++ presenters more prestigious than I am, and also appears on cppreference.com. And like, it's so generic, you kind of feel it would be good if it was like in a standard library, except probably we'd have to choose a name, and like the C++ reference is called overloaded, and some other people's instances are just called overload. So anyway, if
so this took us about 20 minutes to decipher when we were talking.
Yeah, but
through.
Next time, it's just a single Control V, and it's all done. But let's have a look at the function print address. I just write match, which is spelt in this particular example stood visit brackets overloaded, and then I write the type with some square brackets and some braces and some extra stuff, and then I can print one or the other, and I happen to choose the same name for arg in both things, so it looks the same, but it's actually different. I'm printing one of those. Yeah, it's pretty cool actually, because when you dig into it, because struct overloaded is like a template class that's templated on it's a template parameter packs, and those the classes that it's templated on are the things that it derives from, and then cleverly it brings all of their sub-operator round brackets up into the derived class, overloaded itself, using the unpacking the pack over the operator round brackets. I would never have thought of this myself, but we needed to prove that like Rust is unnecessary. Yeah. And then so apparently in C++ 20 and earlier, you needed a correct me if I'm wrong, a deduction guide, which is somebody who takes you around the types and introduces you.
This one is one of these.
It introduces you to the history behind all of the types in the struct. But in C++ 20 or 23, I can't quite remember. I think maybe it's 20.
I don't remember.
Somebody will tell me when the explicit deduction guide isn't needed. I don't know whether it's.
So we're not showing the deduction guide here, right?
No,
there was some other.
It looks basically the same. It's
incomprehensible.
got the word overloaded. It's got some dots, and it's the obvious thing if you can do this sort of stuff.
And you could spell it match.
And you could spell it. Yeah, I could have written match. Yeah.
You could.
You can put lipstick on the pig.
Yeah.
You could spell it match.
You could make it look identical with a few hash defines, I'm pretty sure.
So the critical problem, of course, is that the address comes at the end instead of after the word match. That's something that you'd have trouble fixing. Well, you can change to visit.
Yeah, that could be fixed in post with a macro. Right.
You just write. Okay, you just write a function
yeah,
called match.
Yeah.
Fair enough.
Yeah.
Right.
There's always
the thing about C++.
Yeah.
It never provides you anything. It provides you
the ability to do what you want.
The ability,
exactly.
especially with these whatever it is that's written at the top of this slide, is very clever.
It is quite cool because, like, in theory, without back in the age-old version of C++ that I still have to deliver for, if you wanted to instantiate a template class, you'd need to provide the template arguments because you couldn't kind of infer that from the structure. This would have been a problem in this example because lambdas don't have a spellable type, except it's not a problem in the version of C++ that I still occasionally target for because we don't have lambdas in that version, so it's like a non-problem. But anyway, those problems have both been created and solved in subsequent versions. And so, yeah, just by having a set of lambdas that could form an overload set of the things that happen to be in my variant, we can do this.
That I derive from
pretty cool.
and are my template parameters.
And it shows how flexible C++ is because you couldn't have done that and now you can.
Yeah, it's amazing.
Whereas Rust has had to have it built in from the start.
Yeah, poor old Rust.
How I managed to sell that as an advantage.
Yeah, as poor Rust programmers who
Yeah, so we can do the same thing in C++, and it's cool.
Yeah.
So,
Yeah, I mean 2.1.
you know, you can just paste this in and change the types. But if you want to understand it, you can have a fun afternoon too. Yeah, I like this. I enjoyed learning about this. It was good.
Yeah, and alternatively, you just, I don't know, would you use the union or just do it a different way?
I think I'll probably still, I mean, if I didn't know about visit and I didn't, like, I had, which I do, if I had parameter pack a version, yeah, I would probably...
or build your own discriminated union?
I would probably just do some sort of if statement over the variant type things or something like that. But this is better, yeah.
Yeah, cool. That's really good. Let's move on. So I was in the middle of raving about how much I like enum types. Another thing about enum types is that they're an excellent way of handling errors where you don't need to have exceptions.
Yeah, I mean, exceptions aren't always the best. I'll definitely grant you that.
Yeah, they're not.
I32, that sounds like int again.
Yeah, so...
on all of the platforms that I care about.
I32 is a 32-bit signed number. This function returns a thing called a result, which has two generic parameters. The first of which is like, I don't return anything, and the second one is string. So what this is saying is that when this function succeeds, it returns nothing. And when it fails, then you'll get a string which tells you the error case.
Yeah. I mean, we could have a void function. We could make it take an error parameter by pointer or references. But yeah, it's not ideal though.
Yeah, you could. So so you can do something like this in C++. This is like really nicely built in Rust. So
It's actually there.
It's actually in the language, and there's some nice facilities around it.
C++ is, it'll be next version.
Yeah, it's always the next version. So there's some nice things built into the language around it, some syntax as well, which we'll see in a second. But yeah, so if our input was outside of the range we expected, this is how we return an error value, and then if all was okay, then we return an okay. So error and okay are the two things that a result can be, the two variants in the enum type. Do I want to get into?
Sorry, so and okay, because explain that one.
Similar to
a built-in thing.
Yeah, result is part of the standard library. Yeah. So IP address could be either v4 or v6. Result could be either OK or error.
Right. Okay.
And option could be either some or none. That's the thing we saw earlier.
So when you say result can either be or OK, but the result is like a template-y thing.
Yeah. So result. So the types.
Is it just saying that the first thing is always referred to as OK and the second thing is always referred to as O?
So if you write, so look at that, the bottom line, OK bracket.
Yeah.
That is saying construct a result.
Bring Lisp back.
Yeah.
All is forgiven.
So that's saying construct a result, and which type of result I want is the OK result.
Yep.
And the thing that it holds is a sort of a nothing type.
Okay.
And the type and the value of a nothing type are both pronounced bracket, which is quite confusing. Well, there's a slightly less confusing example on the next slide, I hope.
Okay, let's go.
In terms of strings, Rust has a strong... I mean, Rust...
strongly typed, you're going to say, aren't you?
Yeah. There's a strong distinction between a mutable string that's held somewhere in memory and can be resized and things like that versus some bytes that are kind of in a fixed location. So when you write double quote, blah, double quote, you're making a
constant array of chars?
Like a constant array of chars.
Hey, we can do that in C++ too.
And if your function doesn't take one of them, it takes a string, then you need to make a string out of it. So string from is the way of making a string.
We get asked as strings they'll just implicitly convert. It's fine.
Yeah, things don't implicitly convert in Rust, and that's very, very good. In the case of strings, it's somewhat inconvenient, but it's still, on balance, very, very good. Okay, so this example is hopefully going to illustrate the result type a little bit better. So this is a function that calls our previous function, and it returns a result, but this time the result isn't like either a nothing or a string, it's a number or a string. So if all goes well,
Okay.
this function returns a number, and if all doesn't go well, this function returns a string, or not just a string, an error bracket string.
Where's it return?
So
The error case? I'm missing it here.
So there's a very nice but quite subtle piece of syntax here, which is the question mark on the first line of implementation of this method. So we're calling the previous slide's function, and you'll recall that that function returns either an OK with no particular return value or an error of string. And this bit of syntax in Rust says, if this expression evaluates to an error type, immediately return with that error.
So it's not up talking.
Oh, it's not just having to raise your tone at the end of your sentence. No.
Tricky thing? Second thing. Okay, input *2. In fact, I could probably fall asleep for somebody reading Rust.
Tricky thing? Second thing.
Yeah. That's an awful lot of stuff for a question mark to me.
It carries a great deal
syntactic sugar, is it? It's like
meaning.
Syntactic artificial sweetener.
Syntactic cake.
Yeah, I can. Yeah, I can. I mean, it's almost like you want it to be a pathway of something that would just throw an exception at places that you didn't have to worry about in this code.
Yeah. It is. So the way I see this, and the reason why the question mark is quite small, is because the whole point of it is to give you the cool thing about exceptions, which is that you get to look at the happy path and understand that quite clearly, but you can escape out of that when something goes wrong. But the advantage over exceptions is that it's absolutely explicit at every stage what's happening. And that little question mark, even though it's small, is telling you something very well known about what's going to happen, which is that we will return after evaluating that expression if it evaluates to an error type.
Okay. Yeah.
So you could kind of expand this. I don't know whether I've got that. Yeah. So
again, I can do this in C++.
So what that question mark is syntactic cake for is that this expression, this statement, and that's completely well defined. There are no exceptions. There's no control flow jumping from one place to another. Yeah. It just returns.
Yeah, I think we've got cool new features in C++ that let us do things which are as good as this, if not kind of better, because we're not hiding up too much into a question mark.
Oh, I will correct myself slightly. I did say that Rust makes every conversion explicit, but actually the question mark will try and convert your error type to the return type.
Yeah. So we've got this kind of cool new feature in C++ called StandedExpected. So I could implement something like your tricky thing in terms of and I've kind of tacked the word result on just to make you Rustaceans feel at home. So I've defined it a void result, which is expected either void or string. And yeah, I can do if the input is, then I can return too big. And yeah, actually when I originally was learning about this, which was about 3 minutes before trying to kind of finish my response to the end, and then discovered I could do this. I started trying to construct a StandedInspected object of the right type and make it the dot. And then I discovered that StandedUnexpected is just the thing that you write here, and it looks really natural. And actually, it's a template function that generates the right sort of thing from the thing. But anyway, cool. Still unexpected. It's
like a Monty Python thing, because that's the thing I always love, is that it's called expected, but it contains the unexpected.
Yes.
It's almost exactly the wrong name. It's not expected. That's the whole point.
Yes. Interestingly, StandedUnexpected returns, I think it constructs some type of unexpected expected, and it's possibly not the right type of expected, because obviously I've just given it a string here, so it doesn't actually, I haven't actually mentioned, I can't actually remember how this works, to be honest. I haven't actually...
This is such a great advert for C++.
I haven't mentioned what the first type is, but I think different types of StandedExpected will convert to each other if they are holding either the same. If it's holding an unexpected, you can convert one type of unexpected to another type of unexpected, which is the type that your function is expecting.
Using Spanish Inquisition equals.
Yeah. Anyway, it turns out that you can just write a few words, and in common with the previous feature that we showed, you don't have to understand how all of the details work. It just does. It's really cool. And then returning a void result, you can just return void result, bracket, bracket, or brace, brace. There's probably other ways of doing it too. But anyway, I say that looking at this, and you can either look at it and see that it's as simple as the Rust, or you can look at it and appreciate the amazing machinery under it that makes it look as simple as Rust. Either option works for me.
So I'm not sure I really need to argue anymore on this point, but I will anyway. One of the things about error handling is that, a bit like strings actually, like it makes a huge difference whether, not just whether the facility is available, but whether your whole stack uses that facility, right? So even if you can do all this stuff, and even if you accept that this is a good way of doing it, you kind of need like the entire community of C++ to be using this pattern.
You know, I work at Bloomberg. We have a history of migrating things to use newer features, and soon a lot of our code base will be able to use this. I'm sure
will
we'll
it
be
use
able
this?
to migrate. Anyway, next
Do you
slide.
like? What is the next slide? There was something.
So anyway, and your whole converting an expected to another type of expected can do exactly the same thing here. I would argue that this is like a good good compromise between question mark meaning way too much and having to write like a match. So I can do like void result R is a tricky thing. If not R, which means if R is the unexpected, I can return another unexpected. And again, I failed to say what the expected type would be, but it'll convert fine. But you know, I can create an unexpected and pass the errors kind of down. And then second thing, and return input time too. In fact, the last return statement is quite interesting because like I'm just returning an int, but that'll convert to an expected int quite happily. These implicit conversions are good. They make things neater. Yeah.
So it is very much a feature of Rust that these things are explicit. And in this particular case of returning the happy path value, there is some discussion about not making you write that okay, and there's a bit of disagreement about whether that would be an improvement or not.
Whether it would be okay or whether it would be not okay.
So the only thing I can say about this code is that it's starting to remind me of Go. And
oh dear.
That is not a good thing. Okay.
Okay, let's move on.
So concurrency.
So we'll talk together at this point.
So one of the things that they say about Rust is they talk about fearless concurrency, which we had some critique of in Lucian's talk earlier. And there'll be more Lucian-based critique of what's coming up. But yeah, so it is certainly true that some concurrency bugs that are impossible in Rust that are possible in other languages.
Everything's possible in C++.
Yeah. And there's a few language features that help with this. Including the fact that you can only mutate things if you're the one person who has exclusive access to that thing, and there's control over what gets passed between threads and what can be accessed from multiple threads. It's really cool.
Yeah, so I mean, I suppose I don't have a lot of experience with more recent C++ concurrency features. So, but yeah, I mean. We have full control in C++, and we can do anything we like.
We can do anything, yeah, and that's bad.
We can create race conditions in all sorts of ways, so yes.
So here's some more C++ I wrote.
Oh, yes, okay. Yes, I mean, it's obviously wrong, because it involves the word thread.
Yeah.
Actually, I mean, to be honest, you can probably... you can probably just fix it by putting like atomic around the int, I think. It's incrementing it from different threads, so...
Yeah, so I guess with this example, I want you to imagine that the threads are actually doing some work, but they're also kind of reporting back their progress or something like that. And also that their progress is not just an int, otherwise it's kind of a bit too easy. We could just use an atomic int. But I did compile this and run it, and it does produce like a non-10,000 answer regularly, so it really does not work,
Yeah, that doesn't surprise me.
which is cool. Yeah, so the problem with this code is that multiple
There's a race
threads...
condition.
Yeah, there's a race condition.
Because multiple threads are accessing...
Multiple threads will read counter, and then they're both incremented to the same thing as the other thread, and then it won't have got incremented as much as it should have. So let's write the same code in Rust. So this is a similar thing. Are there any questions about this code? You can see the mute keyword. This is probably the first time I've used the mute keyword in this context. Yeah, letmut.
Letmut. Okay, so
that means that threads is mutable.
Do you mutate threads? I suppose some of them, spawning
I
them
push things. I push things into the threads is a vector.
Oh, threads is the vector, right?
Yeah.
Yes, so you push things into. Okay, fair enough. And you've got a counter which is mutable, so that's really cool. That looks like a for loop to me.
It is,
which is cool because like if it wasn't a for loop, that would be too much surprise, I think. So you're pushing like I guess thread spawn is like a way of constructing a thread on the fly.
Yeah.
And what is this logical OR doing in the thread spawn thing? Just floating there.
So this is the syntax for a lambda function. So it might remind you of Ruby.
Oh, it's like a sans serif pair of square brackets.
Yeah, it's just a more elegant pair of square brackets.
Okay, I mean, yeah.
Yeah, it might remind you of Ruby. So if you have those pipes, that means your argument to your lambda function will go there. Yes.
Is the underscore in front of I in the for loop, is it meaningful?
Is the underscore in front of I in the for loop meaningful? Yeah, it's not that meaningful. It removes a warning. So otherwise we'd get a warning that I is unused. So we could actually, I think, just use a plain underscore and then it wouldn't even be a variable. If you want to give it a name, you can. But it's just to say, yeah, I know it's unused.
Okay, interesting.
You'll notice expect here. Expect means crash with this error message. So beware of expect. In this case, that will never happen. So it's fine.
You mean it would be unexpected?
It will be unexpected. I really hate the name of expect and unwrap, the two methods that mean crash immediately. Or some of the two methods that mean crash immediately. Okay, so we've written the...
I think we have more than two methods in C++, which mean crash almost immediately.
Actually, yeah, I mean, those do mean almost immediately, not immediately.
Yeah, it's unspecified, but the stack of unwinding occurs in this scenario type
right.
things.
The various things happen with the stack in Rust, like you can have a stack trace or not, depending what mode you're compiling in, I think. Okay, so this is approximately equivalent to the previous C++ code. We're trying to update this counter from inside a thread. And you get an error message telling you can't do the thing that is bad. So this is my main advert for what's good about Rust, right? That in this context, that it won't do this bad thing.
Yeah.
The error message
starts halfway across the page, which isn't. It just doesn't give to itself any favour by starting itself so far across, does it?
No, maybe not. But it kind of tells you, like, it's not one of the best error messages of Rust. Rust's error message is generally pretty good, I'd say, but it gives you a clue where to start.
Line box drawing art here.
Yeah, I
so
really like that.
One of them's pointing to the first pipe, and some other of it's pointing to the second pipe, which is kind of cute, but weird.
Yeah, so counter was borrowed mutably the first time around the loop, and then it was borrowed mutably the second time around the loop, and so on. And you can't do that. You can only have one thing. Okay,
so just to go back to the slide again. So what it's saying is that when you passed in the parameter, or maybe when you constructed the lambda that referred to the counter, that counts as a borrow. When does the borrow a runtime action?
Because you mentioned counter.
It can't be runtime. That was a compile error.
Yeah, it's not. No, it's not runtime action. Because you mentioned counter in the lambda function, then the compiler knows that you're borrowing that variable.
Okay.
And it also knows that you're inside a loop, so you're doing this thing multiple times.
Okay, so if it was for I going from 0. I mean, is that an exclusive thing? If it was 0.1, would it know that it only borrowed it once and be okay with it, or would it go?
Probably not. I don't know.
Okay. Okay.
Yeah.
How does that work? Is upper bound on the loop would be a variable?
Yeah. So I don't think it's that clever. I don't think it's that clever. I think it's enough to say this is in a loop, so that counts as it's going to happen multiple times. I'm not sure, though. Yeah.
How do you fix it? So can you actually declare count as atomic?
So how we fix it is a combination of you shouldn't have done it this way, but also you can fix it in a fairly obvious way. So I think there are some atomic ints, but we're going to fix it. Shall we move on to how we fix it?
Yeah, you fix it.
So we're going to fix it
explain yourself.
We're going to fix it in a way that Lucian criticised quite a lot in the last presentation, which I agree with that criticism, right? So, but this is just a direct. You need exclusive access to a thing, so this is how you get exclusive access to a thing. So this is definitely not the way you should do it. But let's talk about what it is first. So
you're constructing a new mutex. And 0 is what?
So 0 is the initial value of counter. Counter is like, well, counter is 0 is the initial value of the thing, the thing you're counting, right? And you're wrapping it up in a mutex, and then you're wrapping that in a reference counter.
Okay, so 0 isn't really like a, it's not like a lock count, you know, because if I saw like mutex new 0, I'd assume you're constructing a mutex, and 0 is some sort of initializer, like.
No,
so actually 0 is
the thing that's being protected by the mutex.
Cool. So when you construct a mutex, you can put it round a thing.
Yes.
And so that 0 is kind of like, it's now mutex protected, but the 0 is showing through up this list of things. So that counter, what does counter refer to? So
counter is an arc that contains a mutex that contains 0. So an arc.
So an arc is like a segment of cell.
An arc is a reference counted pointer.
Oh, a reference count.
And the A is for, so there are non-thread safe reference counts, which are called RC, and ARC is a thread safe reference count, so it can be accessed.
A stands for thread safe?
Maybe it's asynchronous?
Asynchronous reference count. Why
Maybe.
are they all caps? Okay, no, don't answer that question.
So these things are wrapping each other. So we're wrapping our 0 in a mutex, and then, so a mutex can't itself be accessed from multiple threads.
I'm going to throw a curveball in. I mean, could you have like, I mean, you put the reference count, which has to be asynchronous around the mutex.
I think it's atomic.
Oh, is it atomic? Yeah, I think you're right.
Could you have put the mutex round the reference count and the integer?
So you couldn't swap over mutex and arc here because mutexes can't be accessed from multiple threads. Mutex their only job is to make like an explicit.
Wait, sorry, say that again. So a mutex cannot be accessed from multiple threads.
No, you need to wrap it up in an arc.
I think we might, to spite all of the very basic stuff and complicated stuff in C++, we might be winning this one.
Yeah.
Okay.
So yeah, maybe we don't like this solution.
Okay. Anyway, so let's be fair to Rust. You've got a thing that you want to protect, and you wrap a mutex around it. That's actually quite nice because in a lot of my the classes that I have to deal with, I mean, to be fair, the classes I don't have to deal with work fine, but the ones I do have to deal with, sometimes we have like one mutex and a variable, or a mutex and several variables, or sometimes a couple of mutexes and some sets of variables, and it's not always clear which mutex you should lock before writing things. So having a language feature that makes that obvious is, it's not a bad thing.
And then if you look at Java,
that because like, I mean, there's a lot to not
there are problems here. If you look at Java, it's even worse, right? Because you're synchronized.
You just do synchronized
and whatever I happen
to create a bottleneck.
So
or the framework creates a bottleneck for you so that everything works. And then the garbage collector kicks in. Anyway, we're not here to talk about Java.
That's too easy. Okay,
don't kick him out while he's down.
So the point of a reference counted thing is that you can have multiple of them and they all point at the same underlying thing, right? So the underlying thing is the mutex, which is wrapping a number. So in order to pass this thing into our thread via the closure, we need to clone our arc. So the let c equal counter.clone is saying, give me another thing that also points at the same underlying mutex so that I can move that into my closure, and then I can hand that off to the thread. So the keyword move has also appeared there.
So an arc isn't actually a reference counter. It's something that points at a reference counter, because otherwise cloning it would give you...
It's a reference counted pointer.
Okay, yeah, okay. So, but you clone...
It's like a shared
You clone the arc, it's still the one thing, it's just two reference things pointing at it.
Yeah,
Okay.
when you clone it, in this case, yeah, that's a good point. Yeah, when you clone this thing, it doesn't deep clone the whole thing. Yeah.
It's, yeah.
Same is probably true for immutability. So arc is immutable, but the counter itself is mutable.
Yeah, so
Yeah,
that's what mutex is giving you.
See, there's no mut on the counter.
So that's what mutex is giving you, right? So mutex
The
is...
mut is in the X.
mutex is like wrapping something up so that you can modify it, but only when you've taken a lock on the mutex.
Okay. Yeah, this feels counterintuitive.
Yeah, so I spent a lot of time wondering, should I have a mutex of an arc or an arc of a mutex, and wishing that there's a class called arc mutex, which you could obviously write very easily.
The good thing about this is it tells you probably don't want to be doing this. In C++, there's nothing that says, really, don't use locking. It's a bad idea.
Because it looks
Here,
just
it's
as...
just like, oh my God, I have no idea what to do. I know, I'll write good code instead of running state.
Yeah, so the comment is that this looks nasty enough that you probably shouldn't be doing it, which is the right approach.
Name casts.
Yeah.
If it looks ugly, that's good.
It looks bad. So anyway,
Whereas in C++, everything looks equally ugly, so you can't tell the good stuff from the bad stuff.
no, the good stuff that you've been showing.
Yeah, all in one.
So then...
That's next year's talk cycle, isn't it? Thank you.
So then, in order to increment this counter, we need to dereference the reference counted pointer, lock the mutex, and then crash if locking the mutex went wrong, because it won't, I promise you, and then add one to it.
Wait, slow down. Hang on. Well, first of all, what's the move before the lambda?
Yeah, so I actually really like the way C++ does this, but you, in closures, in closures in C++, you can say like how you want to take variables.
Right, yes.
By like
ampersand or equals.
reference or move or something, right? Yeah.
It's a prefix.
What does equals mean? Is that
copy?
Right. Okay.
By copy.
It's really cool, isn't it? And you can do that per variable. So in Rust, you can't do it per variable. You can do it for all or none. So and the two choices are by reference. And if you're modifying it, that would be a mutable reference, kind of automatically, or by move, if you put the word move there.
Okay, so we're going to move everything we capture, and we're capturing C, but
capturing
that's
C.
okay because it's a clone of the arc. And when you clone an arc, you're not cloning the reference count.
You're not cloning a zero, exactly.
Okay,
so normally when you clone things, it's a deep clone. Not in this case.
But this one isn't. I like that links to the bit where you said clone is always a deep clone.
Yeah, well, I'm sure that's me, not Rust, who's at fault there.
Okay.
That's my Stockholm syndrome speaking.
Okay, so we're moving this arc into the lambda so that we can do star first, which is like a dereference.
Dereference,
right? So that's kind of like arc is a smart pointer in
it's exactly like a shared footer.
And so when you dereference the arc, you get like
the mutex,
some sort of reference to the mutex, and then you can lock the mutex and increment the thing that you get by locking it, except there's this unwrapped thing.
So you lock the mutex, and that will give you back a result, right? Which is either that locking worked or that locking didn't work because some thread crashed in the interim when it held the lock, right? So that won't happen, so it's fine. We can just unwrap, which means panic if something you didn't think was going to happen
Value
happened.
Or crash, basically.
Yeah, so I actually do, in the async code that I write that I'm more proud of than this, I do still have a fair few .lock, .unwraps peppered around because I'm like confident that won't happen.
Yeah, feels a little bit less than ideal, but okay. But anyway, basically, we have an in protected by a mutex, and then we have like this reference counted pointer to it, even though, yeah, I mean, in C++, you probably just stick with something that's like a mutex and an int, and pass it into your lambdas by pointer, and then when all of the threads join, you know that nothing else is going to, so it's safe to get rid of it. Okay, so threads.join.
Hang on, we had a question over here.
Yeah, and what happens if you forget to call unwrap?
So Yeah, it won't compile if you don't unwrap, because you're getting back a result.
Because it's the wrong type?
Yeah, it's the wrong type.
So you can't plus
one plus equal onto a result. Yeah. What was I going to say? What did you just say? You asked me something.
We were about to join threads, weren't we?
Yeah, you asked me something. What did you ask me? Like, why are we doing an expect after join?
Yes, maybe I was.
So, again, like joining might go wrong, and you should probably handle that error rather than just crashing like I am now.
Expect the unexpected.
Yeah.
Report join fail.
Yeah.
Okay. And then finally, after all of the threads have finished doing their thing, we print lun exclamation mark. I mean print line, presumably.
Yeah.
Exclamation mark. Print line, excitedly.
Yeah, you should really print this line. Yeah, so println is not a function, it is a macro. And when you invoke a macro, you
have
use an
macros in Rust.
exclamation mark.
You should have led with that. You might have.
Well, the things like debug and clone and stuff are actually macros underneath. But you can have macros that look like functions.
Okay.
And one of the limitations of Rust is that you can't have a variable number of arguments. So one of the reasons why println is a macro is because you want to have a variable number of arguments.
In C++, but sometimes I wish we did.
So the next two slides that are not there anymore.
And we're still star counter dot log dot unwrap.
Yeah, you still have to do the You still have to extract it from your mutex. So the next two slides, which we deleted, were trying to do this slightly better by using a channel to send messages from one thread to the other, and then there's a separate thread that just updates the counter, right? So that would be the nice way to do it, which would be maybe more Lucian friendly, I don't know. But
I decided I'd almost certainly won you, and that would be just digging yourself a further hole.
It was just too much code, unfortunately, so we got rid of it. But yeah, there's lots of ways of doing this better. But so my point
faster actually.
Yeah, my point about why this is
we've live locked.
Well, we're all right. We're not too far from the end.
Are we not? Okay.
My point about this was that even though this is a horrible solution, Rust forces you to face the thing you've done wrong. It finds your bug for you, essentially. And now we're on to the slam dunk.
So I think I'm two points ahead at this point.
Oh, do you?
I'm fairly sure I'm 2 points up. So anyway, packages. So tell me about them.
So I need to score like 3 points or more in this section. Is that what you're saying?
I think there's only 1 point available.
We'll see what people think about that. Okay, so there is a packaging system in Rust. It's actually the best packaging.
Yes, you've won.
Yes, but how many points do I get? It's actually the best packaging system I've used in various different languages that I've used. That doesn't mean it's good, it's just better than all the others, in my opinion. So there's one standard way, which is a huge thing for a packaging ecosystem. Currently, because it's a young language, the main repository of packages has lots of very high quality stuff in it, and probably some that's not, but most of what I've come across is good. Because of the compilation model, everything is source code and it gets built into your stuff when you depend on packages. Part of the build system is to build API documentation with all your comments included and so on, and it all builds offline and makes this really nice local HTML files based thing, which still has search through all the packages that you're using and your own code. You can just search, and the JavaScript within the web browser just locally searches your local HTML files, and it's just really nice to use.
Yeah, okay, so I mean C++ does not address a standard packaging model, but various other third-party solutions do exist. I'm kind of interested to see that everything downloaded and source is built locally.
Mm-hmm.
There are so many targets for C++ that there's no sane way of having. If I had a library that was a low-level library, it can be used in pretty much anywhere C++ lived. Conceivably, it could be put on so many different platforms. There'd be no sensible way of building the version in the way that would be useful to everybody. So I'm kind of interested to see that Rust. Is this because Rust isn't as restricted to targets as I kind of feared? It's kind of is it available on embedded platforms? Museum VAX or something like that.
The current Rust compiler uses the LLVM backend, so it supports all the I think it supports all the targets that LLVM supports.
A limited range of targets.
There's also
the exotic stuff that is available.
There's also a project to build a GCC backend, which I think is like going okay. But I think last I heard, it doesn't have the borrow checker, which is obviously one of the things about Rust that we like. So, more to do, but yeah. Other things about the packaging system, you can, it like handles like versions of packages. You can have multiple versions of your dependencies coexisting.
What a crazy world. I mean, C++ is very, I don't know, very good at bringing up ABI as a scary monster. So
I haven't talked about how Rust lets you target like a C API.
No, that sounds interesting.
Yeah, and you can use C stuff. So anyway, so my sense of the packaging system, and someone mentioned Cargo near the beginning. The reason people go on about Cargo, which is the packaging and build system, is because it's just really just does what you wanted it to do. You can just add a dependency and everything works.
Yeah, it's quite interesting.
Normally.
So when I think about like dependencies and packages and things, sometimes I think more about operating systems, in particular kind of Linux distributions, and many C++ libraries. You can bring into your distribution as a single command, whether it be RPM or whatever the wrapper is called. It used to be Yum, but I think there's a more modern one.
What did Yum turn into?
It's PFK or something. I can't remember.
Surely someone here knows that. DNF, yeah, DNF. Thank you. Yeah.
Which is a really weird thing to call a package manager, because did it download? DNF did not finish. I mean, but yeah, you can apt get it, and there's a pretty C++ libraries have basically inherited the way that C libraries tend to work, in that the header files go in user include, and the library goes in user lib or user lib 64, or there's a link from user lib and it goes into user lib, some arch dependent thing in. Yeah, anyway, but that's kind of basically hidden because your tool chain just uses it if you're using everything from your from the provided distribution. And distributions kind of manage taking the source and having a binary so you don't have to compile it yourself. So I kind of think that in many people's kind of environments, the packaging is more of a distribution and operating system function than the function of the language. So, C++, the standard, and the compiler implementers kind of are addressing a different space, whereas a language like Rust, they've kind of have this as well. I mean, you say that in the Rust package manager you have to download source. Do distributions kind of pre-compile Rust libraries, or is that not a thing?
I think distributions are starting to package Rust applications, and when they do, they'll either be packaging them as statically linked binaries or as you can link to dynamically linked libraries in Rust, so you can package them that way. And I kind of feel like I slightly agree in principle that programming languages shouldn't have package systems, but the fact is that they all do, and there's a reason why they all do, which is
all. I think you just dragged defeat out of the jaws of victory there with that admission. So, and I noticed we only have 10 minutes for questions. Yeah. So I think if we add up the scores, I'm not compelled to learn Rust just yet.
So we've got like 2 slides left, and then you can do your verdict. So just some downsides of the packaging system in Rust. There's no signing of packages or protection against typo squatting, and some things like the JSON handling. That it's not in the standard library. Everyone just knows that you should use serd, or however you pronounce that. But you can look at blessed.
There's a song about that. But yeah.
Blessed.rs for what everyone knows, right? So there is at least somewhere to look. I'm going to not do that stuff. You can ask me about it afterwards. And now you've already said you think
I'm claiming victory, but I don't know if you should have a vote or something democratic. Feels
well. Why don't we ask people whether
questions and then see.
Why don't we ask people whether they're interested in learning more about Rust? It's quite a number of people. Okay, there's some support from the floor for Rust. All right, any questions? Thank you. Go for it.
So I quite strongly
associate the monadic treatment with expected types. Does that exist in Rust?
The what treatment, sorry?
Like the monadic treatment, like
Monads, yeah. Yeah, so yeah, there are methods on things like option that do the kind of monadic type stuff. I read somewhere that they're not technically monads, but it does that stuff. So and there's quite good support for that kind of like calling methods like streaming style or whatever you call it. It's actually, there's a couple of problems with it. One problem with it is some of the methods have got weird names, like and then is different from and, or I can't remember what it is. And there's like, they have odd names. And the other thing is that it's a little bit too compelling because you feel really clever when you use it. And then you end up with this horrific code that is just like a closure inside a streaming style with more. It's not as bad as a normal line of C++, but it's pretty bad. Yeah. Yeah. So yeah, the comment is that if you're looking what's going on, then it's a warning sign. Yeah, and so I think my only point about that is that there's a temptation to try and write stuff in the streaming style because it makes you feel clever, and Rust, just getting some Rust code to compile makes you feel clever already. So
I would say that's not an advantage over C++. Also, making C++.
Programs have the same experience, so they compatible.
I certainly think that people who got addicted to C++ because it's so hard that they felt clever, they're going to feel right at home in Rust.
And then they can check it in with Git.
Yeah. Yeah, I think clever is an insult, yeah.
Having to be clever to just get a simple thing done is definitely not an advantage.
Yeah, and so the way that Rust makes you feel clever is that it criticizes you all the time for all the things that you've done wrong.
Self-esteem issues.
Yeah. So this is where you end up with Stockholm syndrome, because you're brought so low, and then when it finally lets you through the gate and says, yes, your code is correct, you have this great sense of joy and victory. If you ever, the first time I felt like I'd got my head around that arc mutex thing, and then the fact that I needed to clone the arc, and not inside the closure, but just before I went into the closure, I just felt so good about myself.
Whereas when I cut and paste that CPP reference example and it just compiled, I thought, that's cool. And then I tried to work out how it worked, and then I felt really clever.
/ it broke your spirit forever. Other questions?
Everyone wants to go and learn Rust.
All right, well, I think I win from the number of people who want to look into Rust, but I did kind of cheat, because if you write a talk title for people who want to look into Rust, then obviously you're going to win that vote. All right, thank you very much.